Yeah, hello everyone. My name is Evgeny and I'm senior software quality engineer at Red Hat. I'm working in testing farm team and today I'll talk about testing farm integration into Konflux CI. So why we are all doing this? The main goal of this integration is to automate functional testing of container images and in future RPM builds into one environment and also provide reusable, shareable Tekton pipeline. And in this talk, I'll shed a light on how integration pipeline works in Konflux CI. I'll show you how the Tekton pipelines looks inside and share a way of testing the integration pipeline and setting up a CI for it. First, how many of you know about Konflux and testing farm? Yeah, okay, not everyone. So let's catch up quickly. Konflux CI is an open source Kubernetes native CI/CD platform focused on the end-to-end software supply chain security. It is built on top of Tekton pipelines and designed to run entirely inside your Kubernetes cluster. Testing farm, on the other hand, is a testing system as a service. It abstracts the complexity of managing your test infrastructures in hybrid cloud environments and is commonly used as a test execution backend for other services and CI systems. You interact usually with API or CLI, and if you want to learn more, check our docs, watch our DevConf talks, or come chat with us. And finally, last piece is Tekton. It is a cloud-native solution for building CI/CD systems. It consists of Tekton pipelines, which are Kubernetes extensions that installs and runs on your Kubernetes cluster. It is basically, I would say, it is a Kubernetes manifest on steroids. And here's how it all comes together. Whenever a developer creates a merge request, Konflux picks up the event and kickoffs the build. As a part of builds, it runs several integration pipelines. One of them is testing farm pipeline. So this pipeline runs testing farm request, testing farm spin up a fresh virtual machine for you, maybe not virtual, and run all the tests in the repository and report results back to Konflux. And Konflux reports results back to merge request. And let's get into technicalities how the integration pipeline works. The pipeline consists out of 4 tasks. First one is pre-process. Currently, this task only job is to generate the name of the pull secrets for the corresponding component you want to test. And pull secrets are basically credentials used to authenticate to private registries. And as you can see in the manifest, it exposes pull secret name result pass parameter, which is then stored in pull secret name results. It will be useful later. In the this is a script of this task, pretty straightforward. It generates this name until user specified something else. Next one is a scheduled task. This is the main task. It collects all needed information and parameters used, which is used then by testing farm. It creates test request and saves URL to results for further investigation. From this snippet of Ansible manifest or Kubernetes manifest, we can see it uses a pull secret name as a pull secret volume, and it also mounts testing farm secrets. It is secret with a testing farm token inside, so we can run testing farm pipeline. Here is the bash script for it. In the first 2 lines, we are exporting testing farm API token and prepare secrets files. with the pull secret name we generated earlier. Then I cut the script, but there goes. Sorry. We generate and parse parameters needed for testing farm, and finally we run testing farm CLI which send request to testing farm service. And in the end of the script, we are storing request URL for further investigation. The next task: wait for results, wait for testing farm until it finishes, and then parses the output and reports results back, like test output and artifacts URL back to Konflux. Yeah, it's again script, but it uses Python scripts in it, so we won't get into such details. Last task is a workaround of Konflux CI strange behavior. It have bad visibilities of failed tests because it relies on non-zero exit codes, but our CLI exits with 0. I think if a test fails, so we need this task to process the result returned by testing farm and fail if it is not success. Okay, if you would like to test your containers inside the Konflux CI, you will need several things. First, you need to initialize TMT in your repository with TMT init command. Then you will need to know that a pipeline exposes trigger commit and initiator is Konflux TMT context, which can be used to filter plans you want to run or don't want to run in Konflux. And here are three plan examples. First one is basic one. It will run everything on every platform in any case. The second one will be run only in Konflux because we added a just section which disables this test when trigger is not commit and initiator is not Konflux. And the third one is the reverse of the second example, so it will run everywhere except Konflux. The last section is needed for all three plans because it runs the playbook that takes care of setting up your auth file for Podman and pulling the images. Without that, testing farm won't be able to pull your container. Okay, so we are now know about how the pipeline works. So we want to test it. And while developing the tests, we had to overcome a few challenges. First one, we quickly discovered that the production Konflux CI cluster wasn't set up for experimentation and it didn't expose the CLI commands we needed. So we spun up our own throwaway Konflux CI cluster just for testing, and for every test we deploy a new Konflux CI cluster. Also, nobody thought to let us fire off the integration pipeline with a command line, so we couldn't automate our tests. Our workaround is to create a dummy repository and faked match request commands to kick off builds in Konflux. So we are basically imitating the real-life scenario. And finally, our test cluster in the mock repo were completely isolated. No events could get through. To bridge the gap, we used sme.io webhook relay, so the GitLab comment events would land inside our Konflux CI test environment. And yeah, combine all the challenges and our wish to test every merge request to the pipeline, we came up with CI in CI monster. And first CI is GitLab CI. Whenever developer creates a merge request in our pipeline repository, it triggers this GitLab CI task. This task collects a Git URL. We want to run a branch. It runs a Konflux CI plan and adds several environment variables and secrets to access things like GitLab, Quise, me, and testing farm itself. Here you can see a snippet of the plan. It will run all TMT tests, in our case only one, but it is interesting that it asks testing farm to provide a machine with at least 12 gigabytes of memory, because this is a Konflux CI cluster requirements. And this is our test metadata of the test. It tells testing farm to install needed packages and run this test script which uses Bickerlib framework. Second CI is Konflux CI. Here I'll show you snippets from the test script, mostly inspired by trying out Konflux guide. So first things first, we need to install even more software, extra packages, which are missing from Fedora repositories. Weird, right? But yeah, we will need kubectl for configuring our cluster, kind for deploying our cluster, and Tekton to check the results of the integration pipeline runs. Next, the script bootstraps the cluster. The first two lines increases the iNotify resource limits to avoid issues with too many open files. It was from the guide. And yeah, then we follow again the guide steps like cloning Konflux CI repository, create kind cluster, deploy dependencies, and deploying Konflux CI itself. Then we deploy demo users and deploy image controller. And finally, we are verifying Konflux CI is up. So it should run, it should be running, so we need to configure it. First two lines are creating secrets to access GitLab, SME webhook, and testing farm. Then comes a workaround. In recent Konflux CI versions, SME client is already deployed and spun up, but with the wrong configuration for us, so we delete it and create it again with our configuration what we need. Then we create application and component to tell Konflux CI about our mock repository and mock component, so it knows what to test. And we deploy our integration test pipeline here. Then we are waiting to SME client to spin up, so we can send events to there. And third CI, finally now we can test our changes, but first we need to trigger it. So we authenticate to GitLab and put the command retest to this our mock merge request. And as soon as SME receives the event, Konflux CI builds the container and kicks off the integration pipeline. The pipeline runs and the script's waiting for pipeline to appear. In the meantime, it also logs some debug information if we need to debug something, and it waits for pipeline run to finish. In the meantime, testing farm, integration pipeline triggers testing farm request, and once it is finished, Konflux CI puts a comment to our mock repository with mock merge request with all information about the pipeline, so we can see it is all succeeded. And Konflux CI then reports results back to GitLab CI. And final part of the script. We need to describe pipeline run, check if it runs successfully, and fail or pass depending on it. And here, here how it looks in GitLab CI. So yeah, it has run the testing farm request, which did all of the previous things before, and it took like 20 minutes. Yeah, I think this is pretty much it. Thank you. Any questions? Yeah.
I saw that you're using a lot of binaries that come from some upstream repository, and they're not even pinned with hashes or anything like that. We recently encountered a requirement that we should stop doing that. And I wonder if that is just a Konflux thing, that you just grab stuff off the internet and that's how people work, or if there's going to be a plan to switch to self-compiled binaries, or at least something that's more like a stable reference point, look-aside cache or something like that.
Yeah, sorry, I didn't understand the question.
Can you go back a couple of slides, please?
Okay.
Where you did the setup thing, further back where you start down. Yeah, this is...
Yes, this one, right? Previous. Okay.
You're installing kubectl from somewhere, and I'm wondering if this is just a temporary thing or this is expected the end state.
I would love to install it with DNF install, like from any official repository, but it is not available there. And I thought about using Coppers, but then we don't know maintainers of that Coppers. And these instructions are from like official repositories, documentations, and if you know any better way to install it.
I'm similarly frustrated with the way you how to install all of these Kubernetes-related tools. So I share that, but as Evgeny said, it's not really possible to do it in any better way because this is how the project officially recommends to do it.
It's a bit, yeah, it's frustrating because Konflux sells itself as a secure supply chain solution, and these practices don't really align with what I understand should be applied there. Okay, it is what it is. Thank you.
Thanks for the great presentation. So do you think that some parts of this solution could be somehow like generalized, that like others can reuse it, or maybe somebody else using the Tekton pipelines? Maybe that might be interesting.
I think we can do generalization of this part, absolutely. Deploying, yeah, we can share with everyone else. Maybe to even like secrets can be generalized, I think. But everything else, maybe except integration test, can be generalized. But everything else can be, yeah. And I would like to maybe to create some shareable way to test Konflux because it was pretty frustrating. Yeah.
So I didn't quite get like why is like Konflux not exposing any kind of like interface for you to directly call their API or like?
I don't know. I'm not sure, but as I understood correctly, Konflux is built on top of OpenShift, and to make my experimentation possible in production environment, admins need to give me a lot of permissions. So loads that I can delete any other integration test or component, and yeah, I can mess up things.
So then, is there like some plans to upstream like some of the things that you do over there to make it available?
Yes, this trying out Konflux guy is upstream. Konflux guide is the upstream thing, and I mostly this script is mostly inspired by it, so it's going step by step.
Okay.
Sorry, I want to make sure I get the reference right. So back to the discussion where it's unfortunate that things have to be pulled via curl to get some things installed. There's actually a proposed change in Fedora right now that will, if approved, and it's in the discussion process, about the change to Golang related application packaging, which should make it much easier for us to, I'm the new Fedora project lead. Hi, everybody. To make much easier for contributors to Fedora to package Golang-based applications like Kind or kubectl. And so if that's an issue that people have for reasons other than, I just want the stuff in Fedora, please take a look at that proposed change and see if it makes sense, because it should unblock some of the, make it much easier to deal with moving forward. And if you're interested in that and the proposal goes through, please contribute those things. Thank you.
Thank you, Jeff.
Do we have more questions? We have a lot of time.
So using the setup that you built here, can you show us what a user of that, let's say they built a package and what the tests look like? I noticed you had some slides with 3 options earlier. Is that the totality of it? Or what is the experience for someone who is consuming Konflux and is running tests in testing farm via this mechanism?
Yeah, I don't have examples prepared on my hand, but these plans are pretty basic. So yeah, it is for just for the sake of showing you what can be possible with so little. But you can extend it as you want, so you can filter out tests, and maybe you want to prepare anything else, run a script, any script before testing. And yeah, users are using mostly the basic stuff, but some of them have quite complex setup.
Okay, looks like that's it. Thank you, Evgeny, for your talk.
Thank you.